answering an iteration question. So this is the question, and we're going to have a look where this function here, which I've drawn near where it cuts the x-axis in red, and we're trying to find where the equation equals 0. So we're finding this point here. So this is going to be our root if we call it alpha. And we know that alpha is between x is 0.5 and x is 0.3. So it's somewhere in between those 2 points. And we're told to use this iteration formula. But let's have a look where that iteration formula comes from. So if we write f of x, our function, so 3x e to the x minus 1, and we want to know where that equals 0. So rearranging that, we get x e to the x equals 1 over 3. So x is equal to 1 over 3 e to the x, and we can rewrite that as 1 over 3 e to the minus x. And just rewriting that again, we get x, and because it's an iteration formula, that'll be x n plus 1 to the next x is equal to a third e to the x n, so the previous x value. And we're going to use that iteration formula. Now, asked to find x1, x2, x3, so we're given that x0 is 0.25. And to get x1, we're going to put that into the iteration formula. So we need a third e to the minus 0.25. And I'm just going to go back and put the minus up here. And I get from my calculator 0.2596, rounded to 4 decimal places. Now we're going to leave that number in the calculator, and we're going to use the ANS button on the calculator so we don't have to keep typing in the formula. So I'm going to use the fraction button on the calculator, and at the top of the fraction I put in 1, and then at the bottom 3 e to the power ANS. So I'm going to use the ANS button instead of a value of x. And if I write that a little bit bigger so we can see, so 1 at the top, and at the bottom 3 e to the power ANS. And then press the equals button, and that should come out as 0.2571 to 4 decimal places. I'm going to put x2 is 0.2571, and that's to 4 dp. And then you shouldn't have to enter anything else in the calculator, just press equals again, and that gives you x3, and that will be 0.2578. So we've now got our 3 values for x, the first 3 numbers in the iteration. Now question B asks us to show that the actual root rounded to 4 decimal places is 0.2576. So I'll just write that again, 0.2576. And that's to 4 decimal places. Now, if we just draw the x-axis, so let's say that's our x-axis, and our curve crosses somewhere here. Now, if we round to 0.2576 to 4 decimal places, if we think about what's the next number up, it'll be 0.2577, and the next number down 0.2575. Now if we round and we get this value, what's the smallest that number could possibly have been, and what's the largest it could possibly have been? So it must be halfway between the two values. So halfway is 0.25765, and halfway between the other two is 0.25755. So if it's between those 2 points, then there must be a sign change between these two values. So the f of x value must be positive in one case and it must be negative in the other. So we're going to substitute, but we're going to substitute into the original function because that's the one we're trying to find where it equals to 0. So we're going to do f of 0.25755, and that would be equal to 3 0.25755 e to the power 0.25755, and then minus 1. That's just gone off my page, and in my calculator I find that I get 1.09 times 10 to the minus 4, which is greater than 0. Actually, this one is the one when I've substituted the larger one. So I'm just going to change that. And that will be my higher value. And then I'm going to substitute my lower value. So 0.25755 is equal to 3 0.25755 e to the power 0.25755 minus 1, and I find that equals minus 0.379, and I've got that times 10 to the minus 4, which is less than 0. So since there is a sign change, alpha must be 0.2576 rounded to 4 dp, and that's our final answer.